Everybody. This is Professor Dan at the University of Colorado Boulder. And what we have today is just a little how to get started on our homework video. Um, Most people, their first homework, they struggle with the MATLAB, but let's just go through how to get started on each problem. And by all means, come to student health hours if you are struggling. That's why we have them. So when we look at our R and K homework, we have chapter 1, number 7. And we look at it, and good gosh, it says the alternating stress, SA, and mean strength, SM. And if you don't know what's going on, you might be a little intimidated just by that first sentence. Um, but here's the thing. Here's how we approach it. Number one, what are we talking about? If we look, it says straight lines in engineering. So we take a deep breath and we get back to our skills. What are we trying to do? Well, it's our line, and our tools for our line is y equals mx plus b. And if we have 2 points, we'll be good to go. So by all means, read through all this. Do understand the equation SA equals SE minus SE over UT times SM. But don't get intimidated by all these words. Oh man, there's so many times that the words just throw us off. But what we can do is look at the data. We got 2 points. One, it says SM and KSI is 60 and 20, and SA and KSI is 10 and 30. If we go back to our equation, what's our Y? Well, if we look at it, it's not really in Y equals MX plus B format. It's in Y equals B minus MX. That's a little weird, but that's the key. That's the hard part about these problems. It's not the line. It's not the tool y equals mx plus b. It's knowing how to apply that tool. So if we look at our data, we see that the SM is actually our x data, and our SA is actually our y data. And so if we use our points and use our tool, we can find what y is, SA, as a function of x, SM, and then we can just know that SE is our intercept and SE over SUT is our slope. So that's how to approach it. And it seems a lot more confusing, but what we're going to see in a lot of these problems is that the problem isn't using the tool. The problem is the algebra and getting to the point where we know what tool to use. So again, by all means, if you're struggling and have some questions, come to student help hours. That's why we're here. Figure out where your race is getting stuck, and yeah, we'll get you unstuck. All right, next problem, chapter 112. This is just 3 lines. So we have a line from 0 to 2, we have a line from 2 to 4, and we have a line from 4 to 6. And if we break it out that way, it's 3 problems in one, but each one we're just using our tool y equals mx plus b, solving for that line. Let's look at 22. Uh-oh, another one of these where it's like diodes and voltage and resistance, and what are you even talking about? By all means, read it. You're going to have to know it eventually. But the key is Vs equals I times Rd plus V on. And now we look at the data. Again, 2 points, Vs and I. And so if we look, Vs is on the side it's isolated. That's our Y. So we have 2 points. Each one has a Y, 2.0 and 6. And then we look at the right and it says I, and it's 0.035 and 0.135. That's our X. So again, use that tool, solve for M, solve first intercept, and in this case, the M is RD and V on is our intercept. And so that's the thing. The problem isn't using y equals mx plus b, it's knowing how to use it in the context of these problems. It's a little tricky. So yeah. All right, so now 212. Ooh, it says L is L1, L2 over L1 plus L2, but it gives you a bunch of numbers. Plug in those numbers. The hardest part here is the algebra. If you stay tuned to the last video, we might even give you the answer. Might not, I don't know. Um, But yeah, the hardest part is the algebra. Put it into quadratic form, get it into that standard format. Use your tools, that quadratic formula. 16. 16, just like the problem we did in class, just use your quadratic equation and quadratic formula. 29. This one's probably the easiest. Here's what you do. You got to plug in some numbers, but here's the key with these is it has the little m, so L equals 25 m henries. That little m is milli, that's 10 to the minus 3. C has 0.5, that's a mu, farads. Mu is micro, that's 10 to the minus 6. Plug those numbers in. This problem's pretty straightforward. And the last one, we're seeing again, it's not in quadratic form. It's not in the appropriate format for the quadratic formula. So plug in 4,500 for A, do the math out. You know, it's FOIL. Do your FOIL, simplify, put it in the quadratic, that standard format, and the problem's relatively straightforward. But the hard part is you got it. It's the algebra first to be able to enable us to use those tools. All right. But most people, you know, the first homework takes a while and people say, oh, that homework took a while. Sure. But sometimes people struggle with this MATLAB because it's so new. So let's go over this a little bit more detailed. All right. So we open our Gilot book. That's that white one. And it says do problems 1A and B. Well, before we do it, here's the thing. It says read chapter 1, and it says read chapter 2, pages 35 through 46. Do that first. Otherwise, I mean, when we're doing new things, oftentimes the hardest part is all these new words. What the heck are people talking about? So read it, understand it, and then maybe watch this video. And yeah, and any questions, come on over. Um, we got student help hours, we got TAs, we got people who are here wanting to help you. All right, so we read our chapter 1. Now we have to use MATLAB. Oh, geez, intimidating. All right, so we fire up MATLAB and it should look something like this. And we got our files on our left, we got our workspace on our left, and we have this command window. Okay, so we use the command window. We just say 3 times 15. What happens? Oh, 3 times 15 is 45. 3 times 5, 15. Cool. Um, that's neat. That's a really expensive, kind of intimidating calculator. Here's what I want you to do. I want you to hit new script. Fire up a new script. All right. So this is our default setup right here. If we ever lose it, like if we go here and we say minimize, I minimize, where'd everything go? You can go back home, go back to layout, and select the 2-column default layout, and it'll always bring us back. So that's kind of nice. All right, so we got our calculator. We have this area that says untitled, and our command window, we can type in one thing like y equals 42. Oh, that's interesting. It says y equals 42, and now we can see what the workspace does, and that says we have this variable y, and it's 42. That's kind of nice. But we are only able to enter in one command at a time in this command window, which can be very helpful. 67 times 99, okay, that's great. But if we want to enter in multiple commands, we can type in y equals 42, 67 times 99 into this space. And we go to our editor and hit run, and it runs, it says call it something else. So let's say this is homework 0 getting started. All right, there we go. So then it runs and it says, y equals 42, and then gives us the answer of 67 times 99. Now, if you want to clear your workspace, you can say clear all. Boom. That clears all your variables out of your workspace. If you want to clear the command window, CLC. Oh, look at that. So whenever I start a program or a script, I always type in CLC, clear all, and then I'll say close all, because that closes all the figures, as my first three commands. And so that way, whenever I'm running this thing, it's always running new and fresh. If we don't have that, we get into trouble. All right, so now it says um, on our homework, let's see, what does it say? It says do problem 1A and B. Well, I'm going to do problem 2. So what we want to do in MATLAB is always want to tell people what we're doing. So chapter 1, I'll do problem 2A. All right, so MATLAB, there's an order of operations, and it's the same thing that we had in our calc class or our, you know, our algebra class in high school. One thing is when we have a cube root, we always got to know that that's the same thing as raising something to the third. Parentheses are our friend. So I'm going to say 2a. I'm going to assign a variable. You don't have to do that, but it's always kind of nice, is equal to, actually, let's just not do that right now. So I want 8 plus 80 divided by 2.6 raised to the 1/3 plus, and in MATLAB, E is exp to the 3.5. All right, let's just run that. Boop. Answer I'm getting is 46.0385. So I hope that's right. If not, what I always do is I just check it with a friend. Hey, what did you get? So I imagine you can do that. All right, so that's it. It's just using MATLAB as a calculator. It shouldn't be too bad. So let's see the next one. All right, now we got to do 8. All right, so what's 8 tell us? All right, 8 tells us, we got to define some variables. All right, X and Y, and then do some stuff. All right, well, I'm going to do 7. All right, so again, always good to say chapter 1, 7a. And so to define a variable, you just say t. It says define a variable t. Okay, t is equal to 3.2. All right, and now we just use t. So we can say 1 divided by 2. And the one thing is always remember to use the multiplication sign. So when we're writing it out, we don't have to, but in MATLAB we do. So 1/2 e, and we just said e was exp, 2 times t minus 3.81 times t to the 3. All right, now let's just run that. We should get 2 answers. Doop. And we should see t in this workspace right here. So yeah, so it says first answer 46.0385, and then second answer 176.0764. Okay, cool. All right. So yeah, just do that. And again, with questions, come on over. We're here to help. All right, so now chapter 2. Chapter 2, we get in these things called vectors. Vectors start to get weird. But let's see. So chapter 2, 1. It says create a variable A that is a row vector with the following elements, blah, blah, blah. All right. Well, I'm going to do 2. So here we go. So we need a row vector. So chapter 2, 2. All right. So it says create a variable B, and then we learned row vectors are defined by these square brackets. So I'm going to put some square brackets. And a row vector, it says, when we read chapter 2, it says just put spaces between our elements. So I'm going to do square root of 5.2 to the 3. Okay, space. Then I do 6.71 times 10 to the 3, space. And I do 3 plus 5.1 squared times the cosine of 53. But wait a minute, got to be careful. We learned that cosine is defaults to radians, so we have to do cosine of d because it says 53 degrees. Then we do 15.8, 90 to the 1/3, and sine of pi divided by 3 divided by, and now we say it's the tan of 20 degrees, so tan d of 20. All right, let's see how we did. Let's see any errors. Sometimes if you have an error, it tells you. So we run that. Oh, we get this weird thing. This is MATLAB being MATLAB-y. It says 1 times 10 to the 3, blah, 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 and that's all these numbers. I don't like that. So remember, MATLAB said use format long or format short g to see numbers that make sense to us. So we're going to do format short g. Hey, there we go. Got some numbers again. I hope they're right. If not, leave me a comment. Let me know what I did wrong. Now with a row vector, we can also, you can use just spaces, but row vectors, we'll call this B2. Some people like using commas, so we'll show that. So you can put commas between our elements. It's up to you. Kind of like Bob Ross, you know, the artist. All right, there we go. Up, and we see the same thing. All right, let's see what our next homework is. So then we got to do 4. Okay, so 4. Now we start to get into column vectors. So I'm going to do 3. So I just come in here and I say chapter 2, 3. And so if I do C, and that's a column vector. So let me just try it the same way. So if I do 2.1 times 10 to the minus 2 sine of 1.7 times pi, 28.5, 2.7 to the 4 divided by 3, and exp 3. Sometimes when I raise it to 4 divided by 3, I put that in parentheses. All right, so let's just see. All right, so that is a row vector. Column vector's got to be in a column. So the easiest way to do it is you do a column or a row vector, and you can put in a little apostrophe after it, and that transposes it, turns a column into a row vector. And if we do C2 here, if we take C and transpose that again, that'll go back into a row vector. It's kind of neat. Or you can say C is equal to and then take our terms and separate them by a semicolon. That's kind of neat. So we use semicolon, 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 and semicolon. Hey, look at that. And you can see they're all the same. You can also put it on its own line, which I don't know, takes up a lot of real estate. You can show that. You can do that. That works. I don't know. I don't like you doing it that way. But it's up to you. What way works for you? All right, so those are our first problems, and now we got to do our checks. And so, oh boy, we got some checks here. And our checks are, yeah, all right. So it says we want to check chapter 1, number 22. All right, so the hard part there is understanding what is our X and Y variables. Because if we can do that, then yeah, we can use this polyfit command and you'll see it's really straightforward. I'll give you a hint. VS is your Y, I is your X. There you go. But how do we use this polyfit command? Well, let's use, let's see, what's a good one to use? Well, We did have some numbers from class now, didn't we? Um, we did. The other thing we have is, oh, we have this example. So if we have a row vector and our x is 1.5 and 2.5, and our y is 9.75 and 5.85, well, let's just see how to do this thing. All right, so our x is 1.5 and 2.5, and our y is 9.75 and 5.85. Let's see how this thing works. So just say check one. So I'll just say, yeah, x is, and this vector, say 1.5 and 2.5. Okay. Then y is 9.75 and 5.85. Okay. And then I just type in polyfit, x comma y. And when we polyfit of order 1, that is a line. Let's just see what the output is. All right. So we get answer, and we get minus 3.9 and 5.6. And what that actually is your slope is minus 3.9 and your intercept is 15.6. So if you use this information, just, yeah, use VS. VS is your Y. Type in 2.0 and 6 instead of 9.75 and 5.85. And I is your X. So type in the values that you see, 0.035 and 1.135. Use polyfit and it should be the same answer that you got earlier. All right, then we have check 2. So check 2. So really straightforward, but yeah, maybe tricky for you if you haven't done it before. All right, so we need to check our answers to R&K Chapter 2, 12b. So R&K Chapter 2, 12b. Ooh, that's this one. Ah. All right, so the hardest part, like check 2, Chapter 2, 12b. So again, let's go through our our roots example. And so if we have a function that's 1x squared plus minus 6x plus 5, the coefficient factor, the first coefficient is 1, the one in front of the x squared is 1, the minus 6 is your second term, and 5 is your last term. Then you just do roots. And so this is the equation we used in class. So let's just try this. So roots 1. So answer 2. I don't know, call it whatever you want. Maybe not answer. Call it check 2 is equal to, and then we type in 1 minus 6 and 5. 1 minus 6 and 5. And we know earlier that we should see that the answer is 1 and 5. We just type in roots, check 2. Let's see what we got. Oh, look at that, 5 and 1. That's great. And so the last thing we can do, it's like, all right, is there a way that we can check the work that we did? Well, sure. If we went through and did the work, we should see that we had a number that was, for 212, it was L squared plus 140 L minus 2400. All right, so if we do check 2, what's our first value? 1. What's our second value? 140. Call this check 3 is equal to, and what's our last value? Minus 2400. We do roots, check 3, we get our answer. We see that one's minus 240 and one's 100. Interesting. One second. What's 80 times 300? Yeah, that's great. Okay. Um, so we know only one of those answers is actually valid. I'll let you think about that. Um, but yeah, that's how we do MATLAB. Hopefully that'll get you started a little bit. I hope that helps, and I will see you in class. All right, have a great one. All right, actually, I'm going to do one more polyfit example, and let's just do that one from class. So we had our car, it was going fast, or maybe it was going fast, I don't know. But we had two data points, and it says we said that the time was our x, and that was 0.75 and 1.25. And then I had our velocity. Let's call this t. Let's call that v. And our velocity was 35 and 2.4. So let's just see if it works. So if our x was t and our velocity was our y, let's just see how that works. And if we look, we see that the answer was our slope was minus 65.2 and our intercept was 83.9. And hey, check that out. That matches our class work. So yeah, that's how you use polyfit. Just another little example there. If you have questions, by all means, come to student hours, student help hours with me or the TAs or me and the TAs. And yeah, look forward to working with you. All right, have a great day and we'll see you soon.